Hello and welcome. Today we are going to talk about finding area under a curve, and we are going to use a wonderful piece of software called Desmos. So you just go to desmos.com to get started, and the equation we are going to use is y equals negative x squared, negative x squared plus 4. Okay, so the instructions tell us to write and evaluate a sum to approximate the area under the curve for the domain x is in between 0 and 2 inclusive. And then we have two parts we need to do. Part A, we need to use inscribed rectangles, half a unit wide, and then part B, we need to use circumscribed rectangles, half a unit wide. Okay, so the first thing we're going to do is, let's hide this keyboard since we have our equation already typed in here. And I think if we click over here, those gray dots will go away. So we need to set this up such that the units are going to be half, well, it looks like half a unit wide already. Let's see, because here's 2, so that would be 1, so certainly they're half unit wide. Now if we go over here to projector mode, it might give us a little better view here. Yeah, let's kind of zoom in and see what happens. Oops, I zoomed in the wrong way, didn't I? Okay, there we go. Okay, so that looks just wonderful there. So we have, so they want the domain from 0 to 2 inclusive, half a unit wide. Well, it's perfect. This setup is perfect. So what I'm going to do is I'm going to hit print screen. Go ahead and hit print screen here, and I will go and open up my Paint program and paste this into Paint. Control V, there we go. And then the chunk I need to work with is, I just select, I'm just going to select it to about here, so it looks pretty nice. Okay, then I'll copy that, and then I can paste it in here, and I can paste it again, and now I have one for part B and one for part A, one for part A, one for part B. And now, so from 0, let me start with what do we want? Inscribed. Okay, so inscribed, I'm going to choose this rectangle here, and let me get a nice color, maybe gray. So inscribed, when it's a half a unit, the inscribed rectangle is going to come in, meet the curve at a half there. So area under that part of the curve is, look about like, oopsie, about like that. Maybe I got it a little too wide. Okay. And then I'm going to line up my cursor right here. Maybe it's better to use I'm trying to use the mouse to do this. Okay. There we go. And right here, so that's half, 1, 1.5. It meets the curve right here. And then at 2, it just simply, there's nothing there. So I guess I could kind of fill this in. Let's see. Maybe I could fill it in like this. Or you know what? I'll just print this out. Probably what I'll do is just print it out and worry about filling it in with my pencil. Okay, so these are the inscribed circles. And then I'll do this one for the circumscribed circles. Rectangles, rather. I'm sorry, not circles. So, so circumscribed is going to be, the rectangle is going to go right here. So then I'm going to find that the curve is going to meet here from 1/2 to 1, and then it looks like the curve from 1 to 1/2 is going to line up here, and then again from 1.5 until 2, looks like the curve meets right there. And then I'll have to evaluate these after I print this off and evaluate the area here. Okay, so we find, let me just put pause on this. Let's see, Control Shift. Okay, so I probably should have started out with this screen, but here we've put it all together. So we would simply, after we print this off, we simply want to shade these rectangles in, and I copied out the function here, y equals -x² + 4, and here are our inscribed rectangles, and over here are circumscribed rectangles. So what we want to do is, we know that our sum function is going to look something like this. I tried to type this in, but I couldn't find anything that would type it in real nice, so I apologize for how sloppy this looks, but the area is going to be equal to the summation of 1/2 f of a sub n from 1 to 4. Okay, so we are going to work with that, and first of all, we know that we're going to have, since we were told that each rectangle was going to be 1/2 of a unit wide, and we needed to go from 0 to 2. We know we need 4. We know we need 4 rectangles. So that's why in our formula we have 1 to 4, and 1/2 is the width of each one. Okay, so now what we need to do now is we need to place, we need to know where a sub 1, a sub 2, a sub 3, and a sub 4 are going to go in each one of these, so we can properly evaluate. So for the inscribed rectangles, we find out where the first triangle, at what point does it touch the actual curve itself. So that happens right here. So that's where a sub 1 is going to go. So when this function equals 1/2, that's where we're going to have our a sub 1. We're going to evaluate this guy right here. A sub 1 is going to happen at 1/2. And then you notice it touches the curve again here at 1. So a sub 2 is going to be, we'll evaluate the function at 1 for a sub 2 for our second rectangle. And then next it touches the graph here. So our a sub 3 is going to be at 1.5. And then finally, we're not really showing a fourth rectangle, because what happens is the graph touches right here at the axis, but that's where we're going to evaluate a sub 4 right here at 2, where that happens at 2. Okay, and then for the circumscribed, we notice that the rectangle here happens to be connected where x equals 0. So our a sub 1 is going to go right here at 0 where x equals 0. And then right here a sub 2 is going to happen when x is equal to 1/2. So our a sub 2 goes right here. And then a sub 3 happens right here when x equals 1. So we'll evaluate how tall that rectangle is there. And then finally a sub 4 is going to happen right here at 1.5 for our circumscribed rectangles. And this is true because we have a frowny face. Now, if it were a smiley face, it probably is going to look a little different. Okay, so what we would do next is we would take our formula. Let me move that over here. So now that we have our inscribed rectangles and circumscribed rectangles labeled, and we have our formula to calculate the area with using summation notation, we're simply going to say that the area equals 1/2 times the value of the function at a sub 1 plus 1/2 of the value of the function at a sub 2 plus 1/2 of the value of the function at a sub 3 plus 1/2 the value of the function at a sub 4. So we will simply, our next step will be simply to say that a sub 1 equals 1/2, a sub 2 equals 1, a sub 3 equals 1.5, a sub 4 equals 2, and we're going to evaluate the function at each one of those intervals, and then just simply add that all together, and we're going to come to an approximate value for area under the curve for the inscribed rectangles. So that'll give us the area of this rectangle, this rectangle, this rectangle, and this rectangle. So obviously this area that we're going to calculate here using inscribed is going to be less than the actual area under the curve. Then we'll take those same values, some of those same values, and we're going to calculate the area under the curve for the circumscribed rectangles. And only here we're going to change the value of a sub 1 is at 0, a sub 2 is at 1/2, a sub 3 is at 1, and a sub 4 is at 1.5. So I'm going to leave that part of it up to you, and if you want to hit pause and work those calculations out, I will share the correct answers for you next. So I hope you had fun working through that. And for our inscribed rectangles, the area under the curve here should equal 4.25 square units. And for the circumscribed rectangle, our area should equal 6.25, 6.25 square units. So hopefully that's helpful for you, and thank you for your time, and look forward to seeing you on the next segment.